Good morning, everyone.
Morning.
O'clock in the morning has come. Time to show you the marvels of derivatives.
Dad, can I go frog in the class?
iPad is acting slow. We'll give it a second.
The joys of raising a 5-year-old.
Yes, you are in the throes of it.
Yes.
I raised 3 youngins, so I feel your pain.
Well, and so the terrifying thing is like when I was deployed, my last deployment, my wife was a stay-at-home mom, so she spent like all that time like teaching him, just buying like all kinds of learning books and teaching him all kinds of stuff. So like the way he talks is way more grown up than most kids his age because he's only ever been around adults.
Yeah.
So like he talks like an adult. He's way advanced for his class level. So it's like, why are you so smart? Like he's got a mind like mine where he can look at something and figure it out.
Yeah.
So it's like I have to take extra steps. Like he took apart a door the other day. I was like, how did you do that? He's like, I got a screwdriver. Like, what?
That's awesome. In a sense. That's why you're taking calculus, to stay a step ahead.
Yeah.
Then.
Yeah, I didn't even. He's like, I went and got it out of the tool drawer, and I was like, oh my god, child, it scares me.
Let's see. I seem to be having issues here. Do I need to be on Wi-Fi to do this? I don't think I do, but in case I do.
Wait.
Like right now, he's logging into Zoom on his own. It scares me.
Wait.
I couldn't do that when I was 5. I was more worried about Tonka trucks.
No. I'm just trying to log in now. I'm an adult. I guess I did need to be on Wi-Fi. Anyway, I think I have my Wi-Fi issues solved, but because I put a new router in yesterday, so we'll see if that actually works. All right, I got something awesome to show you today. It is the backbone of calculus, and it is the derivative. So we are actually sort of officially starting, in my opinion, officially starting calculus today. Not that you don't need to know the precursor of the limit that we've been discussing, because it's going to be a part of our discussion today and has been for the last couple of days. But the backbone of calculus is the derivative, Calc 1. And I've been mentioning to you that this is our secret. You are now in on the secret. You tell everybody that you are studying derivatives and they think you are awesome. And they don't think they can understand it. But it's our secret that it's really just slope. It's not hard. Now, you've probably used the word derivative in a sentence before, just not in the context of calculus, but it's actually one of the rare times when mathematicians did a good job of choosing the word for this. Now, of course, you might think, you know, why didn't we just call it slope or something? And you wouldn't be wrong about that. But the word you've used derivative for, let me see, I just looked up a couple examples. Like, for instance, did you know that penicillin, I wonder if I'm spelling this right, is a derivative of a fungi? So I amused myself early this morning on my phone by just kind of searching around, like, you know, where do we get different products? And in our culture, because of the, time has passed and so forth, we've sort of figured out the chemical component of some of these things, and then we synthesize them. Like we aren't just getting them anymore straight from nature. Or another one is aspirin that I found. Aspirin is a derivative of willow bark, for instance. And again, we figured out the chemical components of that, and so we just kind of make it ourselves instead of stripping it off bark. One thing that hasn't changed actually that I saw is car wax is a derivative of a palm leaf and so forth. And my point is that's the context in which you've heard the word derivative before, or maybe morphine is a derivative of the poppy plant, which is something we get from something, and that's the whole concept of a derivative. And so it's not complicated, and it's a good name for it. And so we want to tackle that exact problem. Except I want to show you something, and we've already done this. Like we did this yesterday. You already know this. But I want to show you kind of an even better method for getting at this. Before I forget, because I am going to forget, I suppose I should share this just to make sure that you are seeing it, since we haven't looked at it before. But if I share my other screen and I go into my open math, so you may remember that on the syllabus, there's some take-home quizzes, and those are starting now, and they're already all sitting in here for you. But I didn't put one in chapter 2 because we're not going to test chapter 2. We just kind of briefly introduced it so you understand what a limit is so we can get on with it. But in a sense, chapter 3 and 4, now we're getting kind of serious and we're going to get after it. So if you go into chapter 3, along with, and notice it's kind of broken into 2 parts because there's 11 sections in chapter 3. So that'd be daunting to do all 11 sections and then take a test. So we're going to do the first 6 sections. Your syllabus shows you this, and then take a test over the first 6 sections, and then we're going to do the last 5 sections and take a test over that. But notice this take-home quiz up here. Your syllabus says the due date for it, and one of the things you've got to work out is how you're going to scan that and send that to me. We'll talk about that later, but it's not due till like the end, like right before the test. And again, my motivation for this is to kind of prepare you for the test by giving you questions that I think are good, that you'll see on the test, but also that I want to be able to grade some written homework and hopefully work out the kinks in your understanding before the test. I mean, in the end, if you get a good grade in the test in this class, I want to see a good grade in the class. In a sense, it's totally fine to screw up along the way. It's just, do you leave understanding the material? That'd be awesome. So I'm going to give you the best grade I can if you leave understanding it. You should get 100% on this. The reason is because you're getting it right now and you have all the time you want to stay after class, to meet with other people and ask questions about it. I don't want you just floundering on this. You're more than welcome to stay after and say something as simple as, hey, for question 2, I got 19. Is that the right answer? And I'll say, yes, good job. And that'll be the end of the discussion. Or I'll say, no, it isn't 19. And maybe you'll show me what you did. And then I'll give you some hints and so forth. Or you'll just tell me, hey, I'm just stuck on this. Can you give me a hint to get started? So compare answers with other people. Obviously, you need to do your own work, but compare with other people. A little hard to do that. A little harder to do that in this setting, I know. But if you have an opportunity to share with other people, awesome. And then it's kind of delineated like 3.1 right here. That's what we're talking about today. I mean, there's a few questions about that. You should understand how to do these after today. And it'd be actually good if you went and did them today. Like, don't wait till the night of the due date to do it. Do it as we're working so that you're making progress. But those are sitting in there right now in my open math. So in the end, what you're going to do is scan this with your phone or with an iPad or something. Cam scanner is a scanner with your phone, but the main thing you're going to have to send me, and it would be nice if it wasn't scanning like 6 separate pages, but you scan all 6 and send it to me as one big PDF document. And then in that way, I'm going to be able to write on it on my iPad and grade it sort of electronically and then send it back to you. But I want to provide feedback, and I'm going to give it back to you in time for you to learn from it. I'm not going to give it back the day of the test. I'm going to give it back the day before so that whatever's screwed up on it, you'll be able to learn from that in time to, ace it on the test. So that's my intention. In a sense, this is just some hand-in homework. Everybody's doing that at RCC. It's just that I made my own questions rather than saying do question 19 in the book. So anyway, that's cool.
There's a student version of Cam Scanner. If you can provide, like, if you can log into your student email, if you know how on Outlook, there's a student version of Cam Scanner that has like no ads and stuff.
Yeah, it's awesome.
Yeah, and I would like, just given that you're probably more technologically savvy than I am, that we would kind of have a conversation about that here, so that we can all learn from each other. You know, you put something in the chat about how you found it on the iPhone, just in the regular Note app. So Cam Scanner, I think, is for non-iPhones, but iPhones, if you just go to Notes, I'm doing it now to see if I remember. Yeah, if you go to Notes, there's a scanner in there, so you can entirely scan it on your phone. And then I haven't decided exactly what I'm going to do to have you get it to me. You could email it to me, but I'm also considering making a Google group that I'll share with you guys, and that way I can, you know, give you stuff in it and you can give me stuff in it, that kind of a thing. Or maybe we'll use Blackboard. I don't know.
I know last term when we had Annie Drollard, she made a first submitting stuff online. She made in My Open Math a page where you could like go in and submit a PDF file, like attach a file and then submit it. And so that's how we turned in all our scratch paper from tests. So that might be something to look at.
I better look into that, because I would like it to stay inside My Open Math. So I will
Yeah,
look into that.
there's a way she made it where you just put like, you select the browse button and then you just select it from your computer, or you could do it on your phone if that's where you saved it, and you could submit it directly to My Open Math.
Yeah, I'll look into that.
It was basically an assignment with like one question, and that question had it let you, like, you know, upload a file to it.
Yeah, well, and I think my only concern is the the questions I'm giving you are kind of outside. I mean, they're PDF documents, and I know you can do it if it's inside My Open Math. In other words, I just give you a My Open Math question and ask for written work. But anyway, I'll look into it.
It was like a printable assignment. Like one part of it was like, you know, the question, and then we print that, and then the other part was like the actual like question, and you'd go in there and you'd submit your document onto that spot, and it would let you choose the file.
Yeah. Sweet.
Kathleen Foster did the exact same thing last term in both her 111 and her 112 classes, where it was a separate assignment in My Open Math, but it had the first question with the directions and the actual like downloadable document that you could print, and then the second part of the question was just a submit button, and you could upload as many like individual pages as you needed to, or one larger document, and she could then open it and grade it manually.
Cool. That sounds like that worked good, Marissa, for you anyway.
Yeah, it definitely did.
Okay, sweet. I'll figure that out. I'll get back to you on that. Okay, so let's take the derivative. Now let's just start with, because again, I'm going to show you kind of a better way to do this. Let's start with a problem we did yesterday. And again, I got to introduce this with the easiest equations that we can. Let's consider an equation that we did yesterday, x squared minus 6x plus 5. And let's find the derivative. And again, I introduced the word derivative early here because it's exactly what we're doing. In other words, we sort of started with fungi, and now we're going to take a derivative from it. We're going to take something from it. So the equation we have is kind of the start, and we say, oh yeah, great, it's a parabola, awesome. But now we're going to get something from it. We're going to get a product from it that tells us about its slope. So that's the concept here. But I want to do it in a slightly different way, and that is this. This is really cool. I don't know if this made sense to you, but yesterday, let's see, I guess I'll say 2.3. This is actually the way we did this. We found the slope by doing this. We took f of x, and I'm going to erase this, but it was like minus some number like 2 over x minus 3 or something like that. But does it make sense that this 2, in terms of something you would see in the book, or to make it a little more generic, does it make sense that if A was kind of the value that you chose, like a second ago I chose the number 3 for A, and then you come up here and then you actually put a into the equation to see what the y is. Does that make sense? That's kind of the technique we chose yesterday. And by the way, I don't know if anybody has explained this to you in math, but the lower letters in the alphabet, A, B, C, those are letters, but they stand for numbers where you're going to put a number into it like right away. Whereas X, Y, and Z, those kind of stay variables. In other words, to get a graph, the X and the Y stay X's and Y's, and there's thousands of answers for them. Whereas A and B, you know, A is a number. So remember yesterday we said, hey, there's slopes, there's a lot of different slopes on a parabola. And so that's where you actually say, oh, I'd like to know the slope at, you know, the point X is 2. Well, then that means A would be 2, and then you put 2 in, and now you do what we did yesterday. So this is, in a sense, not as good as what I'm about to show you today, because as I mentioned yesterday, if you do this for one number, then you got to do the whole thing all over again. Does that make sense? If you want to do it for some other number. And I want to show you a way to get an entire function that'll actually tell you the slope at any point, and you don't have to do it all over again. That's why it's kind of so cool. So today, here's the logic of this. So I'm sitting here with some parabola. So I'm going to erase this, but yesterday we said, hey, let's go over to this point, you know, X is 2, and let's see what the slope is right there. And again, that's kind of our A. We're saying, oh, let's find the slope right there. A is 2. And then we take 2 and we put it into our equation. And I think I'll do that up here really quick. 2 squared minus 12 is -8, plus 5 is -3. So I think this is the point 2, -3. And then we found this other point up here, x, f of x. And that was cool because we said that is not choosing another point, a second point that's just really close to 2, -3. It's generic, and then we let those get really close to each other, right? And so that's where the, you know, f of x minus a number, just like I'm saying up here, f of x minus a number over x minus 2. But what I want to do today is say, well, you know, is there a way to do this where even that first point hasn't been chosen? Almost like some other point, like this is x1 and this is x2. In other words, both points haven't been chosen. That way we're not specific yet. And then we'll put 2 in later. Does that make sense? There's some way to do that. And you might stare at that and think, well, yesterday we were able to factor it and, you know, have things drop out. But it's like, how are we going to do this, you know, where everything is letters? And we're going to approach this in kind of a totally different way. And here's the idea. So this point down here will be kind of our point we haven't chosen yet. So that's some random point, and that's kind of our first point. Now, you understand this already, but let's just pretend this was the point, say 3, 4. Does it make sense for calculus to work, and we're going to get the slope at the point 3, 4, that this point up here has to be really close to that? In other words, like 3.01. Does that make sense? I mean, that's what we're kind of doing. This is very simple. This is not complicated. But the point is, what do you do to come up with a number right there? Well, don't you take 3 and just add something to it, like a tiny amount? I mean, that's how you choose it, right? You don't necessarily think of, oh, I'm going to find another number. You just think, what do I add to 3, you know, to get really close to it? And so the idea for this is another way to do this that's really cool. How are we going to write the second point here? Well, we're going to say it's the same thing, the same x as it was before, except we're going to add something tiny to it. So 3 and 3.01, in other words, h was 0.01 a second ago, 1/100th. So h is small. And of course, in calculus, we really want h actually to be 0, right? We want there to be no space between them, but remember that wants to explode, and so we got to be careful. And then what, you know, now that we've chosen that 3.01 for our second point, don't we just have to plug it in, that x plus h, don't we have to plug it into the function to see what y is? Now, make sure that soaks in, because this is really cool and this is really powerful. In a sense, it isn't any different, because isn't that still just 2 points that don't have names? It's just kind of a creative way to say it. But now that I've kind of written that, let's just write out like what that says or what that would mean. So if I say I need the slope, then I go y minus y. So f of x plus h minus f of x. There's y minus y over x minus x. So that'd be x plus h minus x. Again, doesn't this look like, you know, good for you? But this is not going to be helpful because there's just letters everywhere.
Well, that's awesome.
Beautiful things happen here. I mean, just beautiful things happen. First of all, what do you notice about the denominator?
We can just cancel the x, right?
Yeah, the x's go away, which is kind of cool. Did you notice that happening yesterday, by the way, when it was like 3.01 minus 3, then what was on the bottom was 0.01. It was like the tiny difference you made between those two x's. Like that happened before. So in a sense, it's not all that surprising.
It was kind of the same when we were like factoring, and then the denominator would go away most of the time.
Right. Yeah, the denominator, and that's what's got to happen here. Now remember, ultimately, we want to let, in our problem here, we'd like to let h be 0. But again, notice if you do it now, it breaks. Do you see that? In other words, the top becomes, well, what's f of x plus h? Well, now it's f of x. So now you have f of x minus f of x, which is 0. And then h is 0 on the bottom. The whole thing explodes. Now, the thing that's kind of interesting is in the first representation of this over here, you can really see the slope. You can see y minus y over x minus x. But notice because of that simplification over here, you can't see the x minus x anymore. And it kind of looks, it doesn't look as much like a slope as it used to look. And so green being my favorite color, this is this entire course. And I'll show you why this is cool in just a second. The limit, because remember, you got to include this. What I said here is true, but it's, you know, you got to say h is 0 in there somewhere. It's the limit. And again, I'll write the word slope down here. Of f of x plus h minus f of x all over h. Like this is going to be sitting in your book, I'm sure, somewhere boxed like that. If there was a way to put fireworks around this and add some 80s Journey music to it, you would do it. Like this is just incredibly sweet. Again, right now you should look at that and say, well, that's a great formula, but it's like, that's not going to do us any good. Well, let's do it. Watch what this does. Watch what this does to f of x up above. So I'm going to copy that and drag it down. So we are going to do what mathematicians call taking a derivative. Let's take the derivative, you'll say. If you say to somebody in class, what did you learn today? You can say, I learned how to take the derivative, which is code for I took the original fungi and I made penicillin out of it. Like this is the derivative. This is coming from it. But what we're going to get this time is an equation. Notice there's no numbers yet. We haven't plugged any numbers in. So we haven't chosen the point that we want the slope. And so what we're going to get here is an equation, a new equation. And this new equation will tell us the slope at any point. Then we won't have to redo this every time. So this is far superior. This is the only method you want to use. You don't want to use this technique anymore. This is, oops, that was a bad decision. This is out. A waste of time. All right,
I love when classes are like, here's this hard way, and then here's the magic way. It's always fun.
Yes, and by the way, today I'm going to show you sort of how to do this the long way, but what makes calculus even cooler is there are patterns that will allow us not to even have to do this. But I want you to be able to build this for yourself. That's kind of the key. So we're going to only play with this formula today, and I'm definitely going to ask a test question about this on it, but we're going to immediately go into the shortcuts. I want you to be able to recognize a pattern and say, wow, I even see a magic pattern where I don't even have to do this. This is amazing. All right, let's do it. So what does this say? Well, this is not hard. Now, The language of calculus. Derivative is a long word, multisyllabic. Derivative. Sounds like 4 syllables. Not cool. Mathematicians hate stuff like that. We got to come up with some symbol for it, right? Are you used to that in algebra now? Like, we got to come up with some symbol for this. That's too many syllables. Where this is in English, we hate this stuff. So there is a symbol for this. Another symbol. If this is f of x, then a derivative is f prime of x. Now, you can't get any lazier than that. That's the smallest symbol you could possibly stick in there. Now, the downside is it looks like an exponent of 1. Does that make sense? But it's really an apostrophe, f prime of x. So it's prime. That's how you say it. So on a test, I would just say f of x is x squared minus 6x plus 5. Find f prime of x. And that's code for go find its slope using this sweet formula. Okay. So f prime of x then would equal. Now I'm just going to follow this recipe up here. I love to think about algebra as recipes. I don't even like to cook, but that's a cool way to think about it. The recipe calls for one of these here, Zambrita. So again, from algebra, we reviewed this last week. From algebra, doesn't this just say stick whatever is here, which is x plus h, stick it right there and right there? It's not complicated. Mathematicians call that a composition of functions. So I'd say, okay, I need x plus h squared, that takes care of that, minus 6 times x plus h plus 5. Again, notice we haven't done anything. We're just plugging in what it says. And then we go on, and now we're going to take care of this next part, minus f of x. What's this person doing wrong? Minus, and then there's the statement, x squared minus 6x plus 5. There's the f of x. What is this person going to screw up?
They need to distribute.
You got to distribute.
Yeah, nice job. Distributive law. Remember I said your algebra mistake every time is distributive law? It's minus all that junk. So you got to put a parenthesis around that to remind yourself, or just change all the signs. It's kind of up to you. I'm not going to mark it wrong on a test if you write what I just said right there, but what I just wrote isn't true. Does that make sense? I'm not going to nitpick that. If you went on to the next step and actually subtracted all those things, then good for you. But I don't know about you, but I'm probably going to screw this up if I don't do something about it. So I'm going to throw a parenthesis in here for now just to make sure, and I'll sort of take care of it later. And then of course, all I have to do is divide by h. And remember, back in the back of our mind, we want h to be 0. But just like yesterday, that's not happening unless that h goes away somehow. So we certainly can't do that right now. But watch what happens algebraically. That's just magical and beautiful. Well, you know how to square, and I'm just going to clean up what's on the top. Actually, I'm going to make a mess of what's on top. X plus h squared is x squared plus 2xh plus h squared. Please tell me you're not still a person that thinks x plus h squared is x squared plus h squared. Again, what's the problem? Same problems every time. Distributive law.
You got to foil that.
Yep. Foil. First, outer, inner, last. It's distributive law. There's more terms than that. And then minus 6 times x. I love algebra. What's minus 6 times x? Minus 6 times x. There's no such thing as math with letters. What's minus 6 times h? Minus 6 times h. And then there's a plus 5. And then after the minus sign, a minus x squared, and then a minus 6x, which is plus 6x, and then a minus 5. Now, would you agree that this just looks like it's going nowhere? Like, this just seems like the dumbest idea you could possibly, just seems crazy. Like, how could this actually go somewhere? But what do you notice about the top? Just start pointing stuff out. Tell me things you see.
Things start canceling, like the x squareds.
Yeah.
All the terms without an h cancel.
Yeah, miraculously, every term that doesn't have an h is going to cancel out of this. X squared minus x squared is gone. Minus 6x plus 6x is gone. 5 minus 5 is gone. What do we have left? 2xh plus h squared minus 6h over h. Which one of those three terms is divided by h up there?
All of them.
All of them.
Distributive law, again, all of them. And they all have an h, which is amazing. Just like yesterday, remember how by factoring, remember how much of a pain factoring was? You don't have to factor here. That's one of the things that's kind of cool about this. But every one of those has an h, and so therefore the h's cancel out, leaving 2x and plus h and minus 6. Would you agree that for the first time, it is now legal to let h be 0? It wasn't legal till just now, right? And so if h is 0, what happens to that term that we just came up with?
It just becomes 2x minus 6.
Just becomes 2x minus 6. So this statement back here is the original. That's the palm tree. And this statement down here is the car wax, which was derived from the palm tree. This was the opium plant. And morphine was derived from it down here. This is the cannabis. This is its derivative. Marijuana, weed, THC. Derivative's a good word for this. So now what you need to understand is what did we just find? How would you describe what we just found? What is that? What does that do for us?
That allows us to find the slope at any moment, doesn't it?
Couldn't be said any better. I don't even have to repeat that. Recipe for any slope. So when you found the derivative, you have this brand new equation now that came from the original equation. That's why it's derivative of it. And this will tell you the slope at any point you want now, not just all this work for only one slope from yesterday. 2x minus 6. Remember that for a second. Let's go over to Desmos, where I have been playing this morning, and you will notice the equation. I have the equation already graphed here. And let me move it so you can see it. See how it's x squared minus 6x plus 5. And I'm going to go over to 1. Notice I'm choosing the point 1. Now, a second ago, what was our formula for slope? It was 2x minus 6. Well, if I'm at x is 1, then what's the slope right there? 2x minus 6. 2 times 1 is 2, minus 6 is negative 4. Notice that slope is really negative 4. Notice I have a little symbol. I can't point to anything right now. I'll take this over to the other screen in a minute, but do you see how there it says f prime of a? Like Desmos is programmed to know what f prime means, and now you know what f prime means. F prime of a is negative 4. 2x minus 6. 2 times 1 minus 6 is negative 4. What if I go to 3? Very important location we just landed at. That's really interesting. What's the slope right there? Well, look at that line. It's horizontal. If I'm at x is 3, 2 times 3 minus 6, hey, that's 0. The slope is 0. Well, look at that. It is 0. We're going to use this. One of the applications of calculus is finding the maximums and minimums of things. Like this is the time, well, you tell me if this is your stock, is this the time to buy or sell?
Sell.
No, you lost all your money. You sold low. This is the time to buy
low.
because it's about to go up. Does that make sense?
I see.
So finding minimums and maximums is a good thing. If you're at the high, that'd be the time to sell your house when it was at the highest value. And so like finding maximums and minimums is a big part of like business calculus, for instance. And so knowing where the slope of a graph is 0 is really kind of cool. And we'll apply it and use that later on. Let's see, let's go to another spot. What about, I don't know, x is 4. Notice over there, it's again, just to stare at the red line, you'd say, hey, look, that's kind of a positive slope, but I'm at x is 4. And when we said our derivative was 2x minus 6. Well, 2 times 4 is 8 minus 6. That's 2. The slope is 2. Sure enough, the slope is 2. Do you see how this is a recipe that tells us the slope any place we want? Now, again, what we're looking at here is just graphically, like, isn't that fun? We found the slope. Like, who cares? It's just some parabola. It doesn't mean anything. But if this was an equation that actually modeled, as I said, the growth of something, then all of a sudden the slope is like the rate of change. How fast is your tomato plant growing? It was dying and you fertilized it, and then it got out of its dive and started growing again. And now you're all excited. Oh my God, it's growing 2 inches per day. We found a slope of 2. So this is what a derivative is. That's what's kind of powerful. That's what's kind of cool.
Hey, Doug, out of curiosity, I'm just looking at your Desmos formulas. Is that y at the very bottom? Is that just showing the line? Would this work without that?
You don't need the line. That's exactly right. If I go turn that off, now you don't see the picture. I just wanted you to see the visual representation of it. And what's so cool about Desmos is notice I had all the lines there. And so if I don't choose values, you see I can just slide this around. You see how that curve is staying tangent? Another side of this is it makes sense if that's a car, that red line would represent your headlights. If you're turning on a road, you're driving on this parabolic corner and the lights are always pointing tangent to the curve. And so there's a lot of applications to this, and I've thought of most of them, so I'm going to destroy you with amazing applications pertaining to this later on. But you see, this is not complicated and it's really beautiful. I think I'll take a picture of this and stick it in the notes, just so that you can, if you want to, you can play around with Desmos a little bit. I'll steal it right there at 2.
I got a question. So before we were finding the tangent line, but then we could calculate the slope of the tangent line. But this, if we were to graph this derivative function, we wouldn't end up with something that even crosses the graph in a good place, but I guess you would just plug in a value, or you could multiply that graph and see what the slope would be.
Yeah, I think I understood your question. You're saying something's a little hollow with your mic or something, but yeah, that's kind of the issue. And so if I understand your question correctly, does it make sense now you can answer questions? And this is the way you would say them. If you said, I would like to know, let me throw this in here. Just so that you're understanding kind of the language of calculus, and also why mathematicians do this, like why the symbols are so cool. So in other words, if somebody says, what's f prime of 2? That's an amazingly packed statement now. You should say, oh, f prime, hey, that's code for slope. Oh, 2. In other words, you want to know the slope when x is 2. And of course, what that means is go to the slope equation, which says take 2 times whatever x you put in and subtract 6. And so you get -2 for that, and sure enough, hey, look at that, it's saying -2. So I can know the slope any place that I want now. And by the way, it's kind of cool because it even works backwards. If you wanted to say, I wonder where I would be on the graph if the slope was 5, you could actually solve this equation to figure out what x would make the slope 5, if that makes sense. So I like the illustration of a recipe. We have a recipe that tells us something about the original graph now that we never knew before this. That's kind of the idea. Let's try this again. But let's see how good you are at algebra. Let's see what time is it. Yeah, we're good. Let's see how good you are at algebra. What if the equation was cubed? X cubed minus 4x squared plus 5x minus 6. A cubed equation. Now you know that cubed equations look something like this. Maybe this one looks something like that. And so notice again, all these interesting slopes. Notice this has 2 places where the slope would be 0 on it, and it'd be fun to be able to figure those out. Before graphing calculators, people really got excited about what I'm showing you because they couldn't cheat. When I took calculus in high school, graphing calculators weren't invented yet. And so, and we're going to do this in this class too, but the skill's a little obsolete because you get a graph for free just by typing it into Desmos or into your graphing calculator. But does it make sense if you were to graph this, if you could locate these 2 points sort of algebraically, that would go a long way toward being able to make the graph of this thing. Does that make sense? So that's interesting. It has 2 places where the slope is 0. And of course, over here, the slope would be positive, and anywhere in here, the slope would be negative, and everywhere over here, the slope would be positive. And so being able to find the derivative is going to, again, tell us a lot about this, but the algebra of this is a little uglier. So let's see if we can pull it off. Let's see, this would mean, and this is going to take a lot of space. F prime of x is f of x plus h. I'm not going to rewrite this, but our magic formula here. F of x plus h minus f of x. Just put x plus h everywhere you see an x in the equation. So I'm going to do that immediately. So x plus h there. And there. And there. And then there's a minus 6. Whoa. So there's, again, my f of x plus h. And then proceed. Minus f of x, so minus this entire thing. Minus x cubed. Look at that, I squeezed it all into one line. It's a miracle. And then all of that is divided by h. That's the definition of a derivative. That's the definition of our slope. And again, I'm being lazy here right now by not saying the limit as h goes to 0. That always has to be there, at least in your mind. Again, I'm not going to ding you on a test, although many, mathematicians would. I'm not going to ding you for leaving that out. But h needs to be 0. Nothing different, right? But what's it going to take to expand that? What do you not like? Well, I don't know about you, but
x plus h cubed.
X plus h cubed is no fun. X plus h cubed is no fun. Well, let's just work it out on the side over here. Let's see, x plus h cubed. Well, I know that x plus h squared is x squared plus 2xh plus h squared, and then I just have to multiply that by another x plus h. So let's just do this kind of slow. So x squared times x is x cubed. X squared times y is x squared times y. There's no such thing as math with letters. And then we do this all over again. 2xh times x is 2x squared h. 2xh times h is 2xh squared. And finally, h squared times everything. X times h squared and h squared times h. There we have that. And let's see, does any of that go together? Do we have any x squared h's? Yeah, we got some here and some here for a total of 3 of them. And we got xh squareds also for a total of 3 of them. Has anybody ever taught you the cool formula, the cool shortcut? Remember I said mathematicians are lazy. They're always looking for shortcuts. Anybody know the cool trick as to how to bypass all that nonsense so that you could even get x plus h to the 5th? Now, I'm never going to give you a problem like that. It's kind of cruel and unusual punishment for somebody to do this with a 4th degree equation, for instance. But, you're a long ways in math. Does anybody know that cool shortcut? Anybody ever show that to you? I'm not necessarily saying, can you tell us all? I'm not going to pick on you, but if anybody have any vague recollection? I'm just curious of people teaching this stuff to you.
I have a vague recollection. I definitely couldn't do it.
Yeah, it's really cool. It's just like, but again, what's kind of neat is you're done with algebra now, which means you're at least decent at algebra, right? You're still learning things and getting better at it and so forth, but you're in a position to take stuff like this in way deeper than you may have before. But this is just cool. It's too cool not to show you. Anybody ever heard of Pascal's triangle? Again, I say that in terms of, have you just heard of it? Not,
I had to do a programming assignment in my C++ class about that, and I had no idea what it even was. And I had to do a bunch of other research that had nothing to do with programming, so I could figure out how to write the program.
What is it? This is Blaise Pascal was a famous mathematician, and this is a part of probability. But it also comes up here, which is rather interesting, and it's a super simple triangle. You're gonna actually go, whoa, that's really dumb. You start with 1, and then, so there's like 1 on the top of the triangle. Then you move down, and now there's 2 numbers in the triangle. And right now it just looks like, what are you talking about? But then you move down to the next row, and the key is every number is found by adding the 2 numbers above it. In other words, there's a 1 and a 1. Oh, those add to 2. And then there's a 1 here, and then there's a 1 here, and then 1 plus 2 would be 3, and 2 plus 1 is 3. And then there's another 1 here, and then there's a 1 here. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and so on and so forth forever. Why am I showing you that? What does that have to do with what we just did? You stare at it and connect the dots.
Well, it looks exactly like the expression that we just made, except for the variables are in there. If you look, it's like a 1x.
See the 1, 3, 3, 1? 1, 3, 3, 1. That's the coefficients. This is how you get the coefficients. And then what do you notice about the x terms? Notice it goes x cubed, and then x squared, and then x to the first, and then x to the 0, like there is no x. And what do you notice about the h's? Well, they do the opposite. They start here at h cubed, h squared, h to the first, and then no h's at all. So as an example, this is just like, I won't even ask you to do this, but if you were sitting there with something like x plus h to the 4th, I could just write it down now based on this pattern. Like that's going to take me a long time to multiply out by distributive law, and there's a good chance I'll probably like miss something and do something stupid. But I can actually just write this out. Since it's to the 4th, and this is the row with the 4 in it, then I know that the answer to this is 1, and then a 4, and then a 6. Oops, I wrote a 6 over here. See, like an idiot. Why didn't you guys bail me out? 1, 4, 6, 4, 1. And then where do the variables come from? Well, the x is to the 4th, and then it's x to the 3rd, and then it's x squared, and then it's x, and then there's no x at all. And what about the h's? Well, this is h to the 4th, this is h to the 3rd, this is h to the 2nd, this is h to the 1st, and there's no h at all. There, I'm done. There's what it is multiplied out. I mean, that's what's cool about math, ultimately. What's ultimately cool about math is there's ways to get things done without having to work so hard, without having to do everything manually. So that's kind of a cool trick. Pascal's triangle. Anyway, where were we? Meanwhile, back with the green pen. So we actually survived the multiplication of x plus h cubed, and all that was just for this first term here, right? And notice this is pretty painful. Like this is a cubed equation. This is pretty painful algebraically. It's not hard, but like the chances of making a dumb mistake and stuff are pretty high. And again, there's a shortcut to this. And I want you to begin thinking about it. I can actually just stare at this original problem back here, and I can just write the derivative down. I don't have to do any of this stuff because of the pattern. So I want you to be thinking, the pattern's not hard to see. I'm expecting at least 3/4 of you to see it on your own. It's real simple. So you might think about that as we're working this out algebraically. So let's see, just so that I don't lose us. I'm gonna drag this thing down here since we kind of got all distracted with good old Pascal's triangle. And so let's see, what do I have then? I have x cubed plus x plus 3x squared h. Notice I don't even have to look at it to write it out because I can just kind of make it for myself. So there's the x plus h cubed. And to save some space, can you do this part in your head? Like, you know, x plus h squared is x squared plus 2xh plus h squared. But then every one of those is multiplied by 4. So it'd be minus 4x squared minus 8xh. Is this right? Tell me if I get it wrong. Minus 4h squared. and then plus 5 times x plus h, so plus 5x plus 5h, and then minus 6. So that's this. This is everything from there to there. This is everything from here to here. Is that helpful, or does that just look like a disaster? And then minus all that other junk, right? So I'm going to rewrite that. So that'd be minus x cubed minus a minus 4x squared. So that'd become a plus 4x squared. And then minus a 5x, and then minus a minus 6 would become plus 6. And all of this is over the top of h, right? Now let's start canceling stuff. What happens every time? We need to divide by h. We need every term up there with an h in it to go away, and it will. So we have x cubed minus x cubed is gone. You can actually just look down the list and see stuff that doesn't have an h. Oh, look, a minus 4x squared. Well, that's going to go away. 4x squared. Oh, look, a 5x. 5x minus 5x. Oh, look, a 6 minus 6 plus 6. Again, don't be shy about asking algebra questions. I mean, you should, in a sense, I can say as an instructor, you should know this, like you studied this in Math 111, but that doesn't mean you're awesome at it. So feel free to either ask questions or, you know, I'm going to make mistakes too. Like all you got to do is lose a negative sign here, even if you know what you're doing and you get the whole thing wrong. So let's see, what do I have left? 3x squared h. I'm actually going to kind of cross them out. And then I've got a 3h xh squared, and then I've got an h cubed, and then I got a minus 8xh, and then I got a minus 4h squared, and a plus 5h. I think I have not missed any, and all of those are divided by h. And of course, those h's all cancel. So now I have 3x squared, since this h cancels. And then this term, there's x squared, I'm sorry, there's an h squared. So I only lose one of the h's, right? So I only lose that 2. And then there's an h cubed. When it cancels with h, there's still 2 h's left. And then the minus 8xh, that h is gone, leaving an x behind. Minus 4h squared, I lose the squared, but I still have an h left. And then finally a plus 5h, but the h would cancel. Now again, what happens last time happens again. Now you're actually free to let h actually be 0. Remember what that means is h was the distance between the 2 points. Clear back here. H is this distance right here. It's like how far to the right did you move? And we just said none. That means the 2 points are the exact same point now, right? That means the slope is perfect. Again, we're touching infinity. We just let these two get infinitely close. Unbelievable. So if h is 0, then that means this term goes to 0, this term goes to 0, this term goes to 0. And now, ta-da! F prime of x is left, 3x squared minus 8x plus 5. That's our slope equation. We now have a derivative equation. We have a slope.
Should we factor it further or just leave it like that?
Totally up to you. Usually you use this to find the slope at any point. So somebody might say, I'd like to know what the slope of this is at, say, x is 1, and then you just put 1 in. So 3 minus 8 is negative 5. Negative 5 plus 5. Ooh, that's interesting. What does that tell you?
That 1 is the lowest point.
Yeah, that's one of the, well, actually, we don't know what's lowest. It's either the lowest or the highest. Does that make sense? We just know the slope is 0. So
that means a vertex, right?
So it could be right there at the bottom, or could be right here because either of those has 0 slope. Does that make sense? So we know it's a maximum or a minimum on the graph. So that's kind of cool. That's interesting. So the point is it's just a recipe to find slopes. And now you could find the slope any place you want to find it. That's kind of the idea.
Should we get used to factoring it right now in case
I would say no. I mean, Faith asked about factoring it. The reason I'd say no is because usually it won't factor. Like the only time these factor is because some math teacher made it to factor. Usually this won't factor. And you could still, if you wanted to know specifically when the slope was 0, as we'll be doing later on, so I won't go into that now, but you could use the quadratic formula to find that, and that's what you should be using. Don't factor. Use the quadratic formula to find the answers that you want to get. In a sense, I just got kind of lucky or unlucky. So I could say, okay, well, that was great. I wonder what the slope is at 2. That'd be 12 minus 16, which is -4, plus 5, I think is 1. So it's like, oh, at 2, at x is 2, the slope, remember that's what derivative is, the slope is 1. And so that's kind of interesting. Incidentally, can you tell me which one of these, based on what I just figured out, can you tell me which one of those two it must be? In other words, I moved from x is 1 to x is 2, and the slope was 1. Which one of those?
It's the first one.
Exactly right. If you move, if this was the point where x was 1 and you move to the right to 2, isn't that slope over there positive? So now I actually could tell that this is the one and it isn't that one. So I actually know now it's a minimum. I didn't know that before. You see what slope can do? I mean, it's like it just gives you another piece of information about the original graph. And so if I was trying to graph this by hand, like, this is good knowledge to have. I can figure out all kinds of things about how this thing is behaving. So cubed equations are a little painful. Fourth degree equations are possible, but kind of out of the question. Like, come on, man. What are you, some kind of a torture? So you're never going to see that from me. And I don't think you will from the book either. Let's try something else before we run out of time. Another example. What about something we did yesterday? Like f of x was, we did a radical equation. So let's make it a little harder this time. What about that? Oh man. Again, we're looking for shortcuts. That was painful yesterday. Remember how I had to multiply by the conjugate to like make any progress with this thing? It's no different today. Like, this is actually still terrible. So the fact that there is a shortcut for this is wonderful. But let's just see if we can pull it off.
I love how you're like, let's do this, but it's still terrible.
It's still terrible. Shortcut's not terrible, but this is still terrible. Remember, though, what you're getting for your struggle, though, is a formula that tells you the slope any place on it. So it's a lot of work, but once the formula is made, you have this little machine, this little recipe now that'll tell you any slope you want. You could have thousands of slopes and you never have to do it again. So it is kind of cool. But it requires algebra. I mentioned in this class, if you got an A or a B in Math 111 or 12, people do fine. If you get a C, that's tough, because most of the algebra, like everything we're doing right now, is algebra. And if you got a C or didn't do well, or it's been 4 years, probably you're like, I can't survive. Well, f of x plus h, well, that just means stick a x plus h in there, minus f of x over h. And again, technically, we need the limit of that as h gets close to 0. Not hard to write it down. But again, unlike the polynomial examples we just did, it's like I can't really do anything with this. Do you understand what I mean by that? Like, I can't multiply it out. The only way you're going to make any progress with this is actually to do what we did yesterday, surprisingly, which is multiply that thing by the conjugate. So this can be done, but we're going to be very happy to know the shortcuts. So you might have all kinds of algebraic ideas that you could do to kind of work with that, but none of them are going to go anywhere, as it turns out. I wish we had time to, I don't know, just play with this more. But you might think, I think I'll square this, or, but remember, the only thing you can do to a fraction is multiply the top and the bottom by the same thing. That's the only thing you can do. And so what would you multiply the top and the bottom of this by? Well, common sense doesn't serve you very well here. As it turns out, the only thing you can multiply this by, got to get myself a little bit more room here. The only thing that you can multiply this by is itself, except with the plus sign. Now, is that okay to do what I just did?
You have to do it on the top and bottom.
Top and bottom. Fortunately, this isn't going to be terrible if you're, I don't know, pretty good with algebra. You have to be awesome with algebra. I don't know. Conjugate. Let's write that word in there again. Again, all this algebra we're doing right here, we're going to do this for like one day, and then we're never going to do this again. For the entire rest of the term, we're going to be focusing our attention on shortcuts. It's important to understand, though, that as complicated as this looks, it's just y minus y over x minus x. So, but the beautiful thing here is what happens on the top?
The radicals go away.
It just clears up.
Yeah, love it. You're seeing it. Because one's a plus and one's a minus, the radical signs go away and there's no middle term. Does that make sense? A second ago, we were taking x plus h times x plus h, and we got x squared plus 2xh plus h squared, right? But if this was a minus sign, just making sure you know this, then you end up with x squared plus xh minus xh minus h squared, which means those two middle terms go away, right? That's the magic of the conjugate. So we're not going to have a middle term, which means effectively you are just squaring the, you're getting rid of the squares. And so now you have 4 times x plus h minus 3 when you multiply that out. And then negative times a positive minus square root times square root minus 4x minus 3. Again, you got to be careful. It's minus all of that stuff, right? Why is that amazingly beautiful right there? What happens to that?
The 3's and the 4x cancel out.
Yeah. You end up with 4x plus 4h minus 3, and 4x minus 4x is gone, and then minus 3 minus a minus 3 is gone. And so all you have left up there is a 4h. Why is that extremely awesome?
Now you don't have an h on the bottom.
Now the h on the bottom can cancel, and the prohibition against sticking in h as 0 has just been removed. And so that's not as bad as it looked, because we don't actually have to multiply out what's on the bottom. That's what's kind of cool here. So that means now there's an h on the top, become red. This h can cancel with this h. Now h can be 0. And now this is really cool, because if h is 0, that means this h goes to 0. Do you notice they're both, now you have the square root of 4x minus 3 minus the square root of 4x minus 3 on the bottom. Do you see that? I'm going to write it just to make sure you understand. And I'm even going to rewrite what we're doing here. We're finding f prime of x. And so I've got a 4 left on the top, and I've got the square root of 4x minus 3 since h was 0, and then minus 4x minus 3 again, right? No, something's wrong. Those are going to cancel.
Why
to
is
0.
it a minus?
So say, shouldn't the bottom, the denominator be 4xh minus 3 plus?
Yeah, see this
4x
plus sign right here? See this plus sign right here? That was supposed to be a plus sign, right? So I screwed up. That's what I mean. That's what I'm talking about. Like, that's why shortcuts are good. I mean, the chances of going all the way through a problem like this and not making some kind of an algebra mistake, not really that good. Again, I'd be willing to bet half of you would screw this up. But what's the square root of 4x minus 3 plus the square root of 4x minus 3? There's a part of me that wants to say, well, you're adding them, so wouldn't that be 8x minus 6? Some of you might be thinking that. That's not true. Again, you shouldn't be making this mistake.
It's 2 square root 4x minus 3.
It already is. If you're saying there's 2 of them and that doesn't matter, or maybe I missed the first part of what you said.
No, I think you heard what I said.
So it can't be what you said because you're saying the whole thing is just.
That would be if it was multiplied together.
This is no different than, I like to think of this as junk plus junk. Aren't those exactly the same? Junk plus junk. What's y plus y? What's 9 plus 9? You have 2 of them. If you're adding something to itself, you have 2 of them. Again, this is why people don't learn math very well. You were taught this stuff, but it was in such a boring, irrelevant context that it's just hard for it to sink in. So if it's just memory, it's definitely gone. And the second thing is reasons. You got to have reasons for that stuff. You got to have reasons for this. What's the real reason? It's distributive law. If you have if those are exactly the same, then that means you could factor it out. And then there'd be a 1 plus 1 left behind.
So that is what I said. I just don't think I articulated it correctly.
Yeah, I was thinking I didn't hear the 2. And so, in this case, hey, the 4 and the 2 cancel. And so I guess you could say this. Remember, the goal is to use this equation. So that's the smallest I can make this, right? Because remember, you're never done here. And maybe in a math class, but in the real world, you would never find this derivative and say, I'm done now. Like, you went to all this trouble to make a tool. I poured molten metal into this form and I built a hammer and then I just put it in the drawer. It's like, why did you build a hammer? To use it, to hammer with it. Like, the whole reason you did this is to find the slope of the curve at some point. So, now I find myself wanting to say, what's f prime of, I don't know, 3? Well, I guess that would be 2 over 4 times 3 is 12. 12 minus 3 is 9. Wow, I am living right. Square root of 9. I got lucky and picked 3. And that gave me the square root of 9. It should have been, the square root of 10 or 11. Remember, you can't take the square root of most numbers. So I got lucky. So the slope is 2/3. And so you could now go to your graphing calculator, take this original statement back here and graph it. And if you went to the place where x was 3, it would have a slope of 2/3. So we have this equation now that lets us find the slope of anything. Amazingly, there's a shortcut to this. We can cut all of this junk out in the middle because people are looking for shortcuts. And I'm telling you that now because I want you to be looking for them. You can actually find these yourself in some cases. It's not brilliant mathematicians that made this stuff. It's accessible to all of us. With respect to algebra, to the extent that you're one of the people, and usually it's about half of you in the years that I've taught this, are looking at that going, oh my God, the algebra is killing me here. Like, don't blow that off. Like, get to the bottom of that. Stay after class, ask me a couple questions. Watch Khan Academy videos. Go re-look at my notes and try to do it yourself. And then come back tomorrow and say, I see that you did this here, but I don't understand why. And I'm going to tell you that's because of distributive law. I can already tell you what I'm going to tell you. It's distributive law every time. Do you understand the distributive law deeply enough? I don't care about dumb mistakes. You're going to make those. Forgot a plus sign, whatever. That doesn't mean I don't understand it. Who cares? I care about important mistakes, like you don't understand the algebra. That's the only thing that'll keep you from understanding this. It's not hard. It's just the grinding of the algebra. Let's do one more example for algebra practice. And then, so let's do yesterday's example, like a fractional equation again. So let's say f of x, the original function we're interested in is, again, make it a little bit harder, 9 over 2x minus 1. And so we're supposed to find the slope, which we'd never say in that way anymore. We'd always say find f prime of x. I'm going to give you a second to just write that on scratch paper really quick. Can you use the definition of slope? I'm going to rewrite it here instead of copying it so you can keep looking at that. F prime of x is equal to f of x plus h minus f of x over h. And we're going to let h go to 0. Ultimately, let h be 0. It's a complicated looking formula, but you should see it as y minus y over x minus x, just slope. Math 60 students understand this. Did you get that? Not hard to write out. I'd encourage you to go slow, like, you know, for a number of reasons, because you're going to make less math mistakes. Become an organized person mentally. Use a lot of paper. Don't squeeze all this into a tiny corner. Don't write tiny. I say that for your sake, just so that you have a train of thought. But secondly, when you take a test, if I can determine on the test, because I can read your handwriting, and I'm going to lose patience really fast if I can't read your handwriting, because I work my butt off when I grade tests to determine, is your mistake stupid, like an accident, like you forgot a plus sign like I just did, or is it like you actually don't understand calculus? If I can see that you understand calculus, you're still going to get a pretty good grade, even if you miss every question. Write it out in a bunch of steps. Make it so I can find your mistake so that I can give you a bunch of points for this question, even if you do something wrong. Now, this is kind of nasty. Like, what do I do to make this whole mess go away? Well, what did we do yesterday? Well, yesterday we wanted those fractions to go away. So for instance, I'll start with the easy one. For instance, we might say, I think I'll get rid of that 2x minus 1. So I'll multiply the top by 2x minus 1, and I'll multiply the bottom by 2x minus 1. Unfortunately, this right here is not 2x minus 1. It's not going to cancel that at all. Remember, it's really 2x plus 2h minus 1. You could rewrite it that way if you want to. I think maybe I will. So another question you should know the answer to. 2x minus 1, does it get multiplied by the top, the bottom, or both?
Both.
Notice where I drew the arrows, because I'm actually asking this as kind of a trick question.
Doesn't it get multiplied by the top, since it's 2x minus 1 over 1 technically?
It's 2x minus 1 over 1, and fractions get multiplied straight across, so it's only multiplied by the top. So basically then this 9, because of distributive law, big minus sign, that should be standing out, big minus sign, distributive law. So that means the 9 gets multiplied by 2x minus 1. And then that statement on the bottom, which I'll multiply out, 2x plus 2h minus 1. Some of you might think, oh, look, I'll cancel those 1s out. Like, you can't do that. That's screwing up. What are you screwing up? The distributive law. So unfortunately, those aren't the same at all. And this 9 gets the 2x minus 1, which of course the whole reason you did this, these are identical, which means those can go away. That's why you did this. And the h gets multiplied by 2x minus 1. So you got rid of one of the fractions. So this 9 over here is just the 9. In the spirit of the pattern of that I'm trying to accomplish here, what's my next move going to be then?
Multiply by the other denominator, 2x plus 2h minus 1.
Nice job. Just do it again, like get rid of the other denominator. So if I multiply by 2x plus 2h minus 1, top and bottom, and I'd encourage you to think about this, you know, like I'm showing you what to do, but really you're just trying to do something. Like I got to do something to this, and the only thing I can think is I hate fractions, and fractions over fractions I really hate, and so at least I can do this. I don't know if it's going to lead anywhere, but at least I can do this. So when I multiply this by this term, of course, that's just going to cancel the bottom out, and so then I'll have just the 9 times 2x minus 1. When I multiply it by the 9, it'll just be there multiplied by the 9. And down here on the bottom, when I multiply 2x minus 1 times h by it, and I'll just have it. Was that good? Like, is that helping?
So why didn't the 2x plus 2h minus 1 go over to the 9 times 2x minus 1 either?
It did. What do you mean? I distributed it because of this minus sign. I knew that I had to multiply it by this, and it didn't cancel. That's why it's still sitting here. Maybe I'm misunderstanding your question.
Well, because we had 9 times 2x minus 1 minus 9, and then we times those numerators by 2x plus 2h minus 1.
Yeah.
And so I expected to get 9 times 2x minus 1 times 2x plus 2h minus 1 minus 9 times 2x plus 2h minus 1.
Yeah, but when I multiplied it times this term, wasn't it up here, 2x plus 2h minus 1? And the whole reason I did that is so that those would cancel.
Oh, God, I missed that. Okay, thank you.
Thank you for asking that. Like, please, everybody do that. I don't care whether the question is an excellent question. I can't answer it all the way down to like something totally basic you should know. Please interrupt. It gives other people time to think, and you're likely not the only person that has that question. Now, my first thought is that was a lot of work for nothing. That did not help because it's bigger than it was before. Like, this is a tremendous disaster. At least it doesn't have fractions over fractions, but it's a tremendous disaster. But why does this actually come out of the weeds and become glorious? Why is this not a dead end?
Stuff's gonna cancel.
Yeah, look what's on the top. Up on top, you have 9 times 2x, which is 18x, and 9 times 1. And then you have minus 9 times 2x, which is minus 18x, minus 9 times 2h, which is minus 18h, and then minus 9 times minus 1, which is plus 9. 18x minus 18x goes away. Minus 9 plus 9 goes away. Why is that all of a sudden? Oh my God, that's amazing. I can't believe that happened. What happened?
It simplified it quite a bit. In the denominator, you put a 2x plus 2x, and I think it should be 2x plus 2h in the second.
Never do math without 20 people watching you. These problems are long enough that and I didn't do that on purpose. And that wasn't the only mistake. There was one of them back here that I caught. Anybody see me fix that? I put a plus sign right over here. It's like I've made 3 dumb math mistakes on this so far. That does not mean I don't understand it, but it's like even just copying your own, reading your own writing. A lot of the mistakes I find in people's tests is they can't even read their own writing. That's understandable because your mind is just, going along. And if you have bad handwriting on top of it, it just makes it worse.
Yeah, I do it a lot.
So of course, what's amazing is this actually came out of the woods, and now this H can cancel with that H. By the way, a little side note from the past, look up really quick. There have been many of you that would have been tempted to do this back here and said, oh, sweet, look, 2x minus 1 and 2x minus 1 cancels. Can anybody articulate why that's algebraically not okay to do? It seems like we're doing that all the time. All of a sudden you're saying you can't. Why can we not do this up here and down here it was suddenly okay?
Because go ahead, Justin.
Times 2x minus 1.
Say that one more time, Justin.
Is it because it's 9 times 2x minus 1?
No, that's not why.
It's because the top is a term.
That's because of this minus sign right here.
Yeah, you have a term basically because you can't take it out of the term.
Can you divide the top by 2x minus 1? Sure, but do you only do it to the left one? No, you just screwed up the distributive law. It's the same thing every time. Why can't you do it, distributive law? If you're going to divide the top by 2x minus 1, then you got to divide this term by 2x minus 1 too. You violated the distributive law. Why can you do it down here in the bottom? Well, because there's no plus signs. You see how it's 18h, that's like one term. And then down on the bottom, notice it's junk times junk times junk. All 3 of those are multiplied together. So this is kind of like 2 over 2 times 3 times 6. Do you divide 2 by every one of these on the bottom? No, because they're multiplication signs. That's kind of what I mean about how much nuance and how tricky the distributive law is. Plus and minus signs are important in the distributive law. Even if you knew that no was the answer up top and yes was on the bottom, I doubt you could articulate that to somebody else if you're going to be a math teacher. But maybe it's just, I don't know, I just feel it. I mean, that's the way I was when I left math. I felt it, and that's why I was okay at it, but I didn't understand why.
So Doug, up on the green problems, we were able to kind of do what you were saying not to do down there because it was staying on one side of the minus sign. Is that why?
That's exactly right. I was looking at that single fraction. I was looking at this single fraction right here independently of everything else and saying, hey, look, they have the same thing on the top and the bottom. In other words, it's kind of like saying, I have, 18 over 3 plus 7. Can't you just simplify 18 over 3 all by itself and then save the 7 for later? Yeah, that's what I was doing. It's a wonderful question.
Got it. I totally fell into that trap. So
yeah, you're going to make a lot of those kinds of mistakes. And again, just take them seriously and get to the bottom of them. Have me explain it to you. Like, why is that not okay? And I'm going to say, here's the nuances of the distributable. That's the only thing you screw up. And so, of course, I'm in extremely good shape now because what happens here happens every time, which is now h can be 0, which means that term goes to 0. 2 times 0 is 0. So I end up with negative 18 over 2x minus 1. Well, I guess times another 2x minus 1, right? And of course, you know what to do with that. I hope. Again, I love to ask students, and I got to let you go here, but I love to ask students things like, what's 2x minus 1 times 2x minus 1? And a lot of times they'll, I know it's 2x minus 1 squared. And I like to kind of jokingly say, you say that like you just did something. Like, you didn't do anything. Like, it's just another way to write it because you're lazy, right? And it's like you're just saying multiply and you're just writing it with a little symbol. There's no such thing as math with letters. You can't multiply 2x minus 1 times 2x minus 1. You can write it differently, but so, what do we have here? Again, we came out of the woods and now we have this amazing little formula here. We don't have time to use it for anything. But what you should do is be testing this. In other words, you should draw this original problem back here. You should draw that in Desmos. And if I had 5 minutes, I'd be doing this. You should draw that in Desmos. And then go down here to your cool slope recipe and plug in x is 3 and x is 2 and x is 1 and look on the graph and go, well, look at that. That does look like the slope would be 2 there. Look at that. It does look like the slope would be negative 5 there. You can tell if this is broken or not. You don't need my open math to tell you if it's right. You should be able to check it yourself and see the visual reality of the slope. You don't have to, do what I did and have a formula where the line slides along. Just go to the point in the graph and say, does that tangent look about like the slope I just calculated? And so, if you're all finished with this, you should know that you got it wrong or right based on how it looked. And as I said, I made 3 math mistakes. Some of them I caught myself, some of them I didn't. And so, my recipe down here could be broken, but if I went to Desmos, wouldn't I discover that? Wouldn't I discover something's wrong here? What's going on? And, that's going to condemn me to at least a half an hour of looking back. And I don't know about you, but when I look back at my own work, sometimes I'm like, oh my God, I can't even read. What did I do? I don't even know where I went. But it's like, it's going to condemn me to a half an hour of trying to find that mistake. On a test, I would love to see a note that says, I know this is wrong because I checked it, but I can't find my mistake. It's a test. I don't have any time. Good for you. If I gave you time, you'd find it, right? Cool stuff. All right. It would be very wise to finish the 3.1 assignment tonight, just so that tomorrow's discussion makes sense to you. Because again, we're going to proceed very quickly towards shortcuts to where we don't have to do all this algebra and that we can skip straight from here all the way to there and jump over all that nonsense. It's amazing that mathematicians found a way to do that. And I want you to have as much chance of understanding that yourself instead of me just showing you the formulas as possible.
So for in Desmos, right? So we would just type in f of x equals 9 over 2x minus 1. And then for a secondary equation below that, we just type in f prime of x equals what we got. And then
actually the best thing would be, you could just get your calculator out and do the slope part yourself, on a side calculator and say, okay, I'm going to plug in, into this equation down here, I'm going to plug in a 2 and just do it on the side. Now, if you wanted to use Desmos for both, you need a second equation, but don't call it f prime of x because it's going to, let's see, is that true? You could just call it g of x, like a totally different equation. And then you could say, what's g of 2? And it would plug it in for you. And by the way, that's what we're going to be doing in class tomorrow, is looking at the graph of the original and the graph and literally the graph of f prime of x, and like looking at the two graphs as a way to kind of check to see, oh my God, yeah, that would be telling me the same thing.
Gotcha.
Good question.
So instead of what you were saying on Desmos, is just like plug in the equation and then solve the slope yourself and then check it with whatever you get, right? Gotcha.
Yeah, it'd be better just to do this equation, the equation that I have on the screen now. It'd be better to just do that in your graphing calculator. Shortcuts are not good if you do them too early. Like, do everything kind of slow and manual and make sure you're kind of going, oh, I see that, and that totally makes sense to me.
Gotcha. Okay.
Other
Bye,
questions?
thank you.
See you tomorrow. Take off if you need to take off. Always 5 minutes over every day. So, but stay after if you want to ask anything.
I had a question on the 2.3 homework.
Yep, go
There
for it.
was one question 7,
Okay.
which is, it's similar to some of the I think the second to last one we did. It's like 1/5 times x plus h squared minus 1/5x squared, and then over 2h.
2/8,
H.
2h. This was 2.3.
Yeah, that's on the 2.3.
And what do they want you to do with that? Like as h goes to 0 or something?
Yeah, the limit as h goes to 0.
Yeah. So coincidentally, that's what just happened to us in this problem right here. Like that looks really similar to what we did right here. Like you didn't know where it came from. But notice you have 9 over ugly minus 9 over ugly over h, and it's like, you know, what is the value of that as h gets close to 0? For that reason, algebraically, given that what I just showed you here is so hard, I'm not surprised you found yourself going, geez, I don't know what to do.
Yeah, I tried many different things. Like I think I did try the thing that we did today with that question as well. I tried several different things trying to like mess with it algebraically and figure out what it was, and I could not figure it out.
Yeah, so from today to crystallize what we tried, and of course, even if you tried the right thing, as I said, you could easily make algebra mistakes, you know, that are either profound or simple. But in the end, I'm going to multiply this by 5x squared top and bottom so that will cancel out. And then I'm going to come back and multiply by 5 times x plus h squared so that this will cancel out, top and bottom. And when I do that, I'm going to, what's left on the top, if you will, is going to have an h in it. And that h that's left on the top will cancel with that h on the bottom, and then I'll be able to let h be 0, and then I can get that limit without having to guess. So again, that's why I give you till Sunday. Like either try that right now, Zamar, and maybe we even have time to talk about what went wrong before we leave. But at the very least, like have some good work, and you know, I'm not sure how your camera works, but I can. But at least you could hold your paper up to your camera, and I could look at what you did, and we could talk about it. Somebody else.
5x squared plus 5h squared. Those cancel.
That's a tough question.
So in this particular problem, then, just working it out mentally in my head, you'd end up with 5x squared over 5x plus h squared minus 1 effectively, right, for that second term, for the first part of it.
Let's see, I multiply this times this and this times this. So the x plus h is squared. So I'd end up with a 5x squared on the top and just a 5 on the bottom.
Yeah.
Let's see. No, that's not true. The 5x squared.
Well, no, yeah, the 5 would go away too.
5 would go away. So that'd just be a 5x squared. And then when I multiplied both of these by this term, the 5x squareds would go, and then there'd be
minus 5x plus h squared, right?
Right.
Henry, quiet.
And then on the bottom, I'd have just everything. I'd have the 2h, and I'd have the 5h squared. And I'd have the 5 times x plus h squared. And then
Gotcha.
hopefully, if I do the math as to what's on the top, all of the x squared terms will cancel out of that. And I'll
Well,
have
yeah.
something that just has h's in
Yeah,
it.
you left with negative 5h squared. But then you can only cancel out one of the h's from that, so you still have negative 5h.
But remember,
over
the
2.
important thing here is that this h cancels out, because that's the one that's keeping me from being able to put h as 0 in. I don't care if there's an h on the top that's 0. A fraction with 0 on the top is fine.
When I do that, I cancel, cause I did that. I canceled out the h, and I had negative 5h over 2 times the like 5x squared, 5x plus h squared. But then if I plug 0 in for that, it's fine on the bottom, but then you're left with 0 on the top, and so it all just becomes a 0.
That's correct, except for you blew the distributive law. On the top, what's x plus h squared? You should have more terms on the top. You screwed up the distributive law. When you multiply 5 out, you don't get to multiply this 5 in here, because the order of operations says you got to square it first. So you got to take x plus h and square it first, and then multiply by negative 5. You're making an important algebra mistake.
All right. Let's see.
Yeah, because that top part would be minus 5 times x
5x
squared plus
squared
2xh
plus 2x8.
plus
Yeah,
h squared.
okay.
Minus, yeah, plus h squared.
That's right. And that minus, so there's 3 terms to that.
Okay, I see. Yeah, all right.
So would it be also smart to
Right.
do that on the bottom as well, to distribute, to do that x plus h squared?
As it turns out, the answer is no.
No.
Only because of time saving. And the reason it's time saving is, does it make sense if h goes to 0, then I just have 5x squared times 5x squared?
Yeah.
So
Well, yeah. Okay, I get what you're saying.
that'll save me some time. Now, is it wrong to multiply it out? No, you'll get the same answer either way.
Yeah, I see what you're saying. Because then you just have x plus 0, and then it's
Right.
just, okay, I see what you're saying.
Super good question. That's a nasty business.
It's still pretty ugly.
Yeah.